So the first thing that you need to be looking at as we do these guided practice problems are these solubility rules. I'm going to refer back to these a few times throughout these examples. Hey guys, so these are the guided practice problems for reactions part 3. I did a couple in class with the people that were here, so I'm making this video so that you guys at home have a little bit extra help. So let's look at the number 1. Aluminum chloride solution reacts with silver nitrate solution to create. So I need to write out my reactants, figure out what the products are, and in some cases I'm going to be writing out the net ionic reaction. So let's see what that looks like. So aluminum on the periodic table has a charge of +3. Chloride has a charge of -1. When I add those together, it looks like this. And since that is a solution, I'm going to say AQ. It reacts with silver nitrate. So silver is Ag, that's a +1. Nitrate's NO3 -1. So it's just going to look like this. AgNO3. That's also a solution, so we're going to call it aqueous. And then we need to figure out what our products are. So let me erase this stuff. Okay, so first, it's helpful to figure out what type of reaction you're dealing with before you predict the products. So I have 2 compounds. That tells me that it is a double replacement reaction. That means that the metals, oops, and this is supposed to say aluminum over here. Let me erase this. That means that my metals are going to switch places in the reaction, okay? So if my metal, aluminum and Ag, switch places, aluminum would now be bonded to my nitrate. Remember that aluminum has a +3 charge, so that 3 would go over here. And then my silver is going to bond with the chlorine, just like that. So silver has a +1 charge, chlorine has a -1, so those cancel out and it would look like that, AgCl. We need to figure out what the states are. So that's when you need to go back and look at that solubility rules paper. The solubility rules say, let's see, which one do I want to do first? I'll do AgCl first. So on the solubility rules, you're looking for the rule that makes sense with this compound. Number 2 on the solubility rules says all chlorides, bromides, and iodides are soluble in water except those containing Ag, and then it lists a few others. So that means this compound's not soluble in water, which is going to make it a solid. Okay? Number 1 on my solubility rules says all alkali metals. Remember, alkali is group 1 on your periodic table. All of those are soluble in water, and all nitrates are soluble in water. That includes both of these compounds, so that's going to be aqueous because it's soluble. Okay, so far I have my equation. Now I need to balance it. Let's see. So I would start, I'm going to kind of write below, and I'll go back and erase it later. I'm going to start over here. Aluminum, I have 1. Chlorine, I have 3. Ag, I have 1. NO3s, I have 1. Over here, 1 aluminum. Chlorine, we have 1. Ag, we have 1. NO3s, we have 3. So I would start by trying to get your chlorines to equal. So if I put a 3 over here, that changes my chlorine to have 3, but it also changes my silver to have 3. Okay? Now my NO3s are not balanced, so if I put a 3 over here, I have 3 of these and 3 of these, and everything is balanced. So to balance it, all I did was add a 3 here and a 3 here. Okay, the next step is to write our net ionic equation. So that's basically your simplified version of the equation. There might be times on this paper goes the bell. There might be times on this paper where if you tried to simplify it, everything would cancel out and you wouldn't have a reaction. So if that happens, which it's a couple of the ones later on, when that happens, you would just say everything cancels, no net ionic equation. So for our net ionic equation, any compounds that is aqueous or it's dissolved in water can be split apart. So this is what we did last class too. So like I have aluminum, I'm just bringing this down. Aluminum has a +3 charge, so I'm gonna write that. I have 3 chlorine, and those have a -1 charge. I gotta keep going. I have 3 silver, which has a +1 charge. I have 3 nitrates, which is a -1 charge. And that's everything on my reactant side. I need to keep going to draw my products. And it's only the ones that are aqueous. So I have 3 aluminum. I have 3 nitrates. Remember, this little 3 tells me that I have 3 groups of NO3. And then I just can bring down my 3Ag, oops, I'll write it down here. 3AgCl. So that one is not split up because it's a solid. We cannot split up a solid. Okay, so there's my ionic equation. I have all my charges written out. Now I just need to cross out anything that looks the same on both sides. So cross that out because it's on both sides. What else? This. That looks like that's it. So our net ionic equation just looks like this. That is my simplified equation. So that would be your final answer for that first question. So any double replacement reactions, you will simplify the equation down to its net ionic, okay? This paper mostly has double replacement reactions, but it may have some combustion. So let's do one of the combustion problems. This one's combustion and this one's combustion. The rest are double replacement. So in a combustion reaction, let's actually do this one. They're actually a little bit easier. For combustion, it's always going to have the same format. So I have my fuel, which in this case is acetone. I'm going to add that to oxygen, O2. My products for combustion will always be H2O and CO2 every single time. So now all I would have to do is balance. Let's see, I would probably try to balance the carbon first. For combustion reactions, it's easiest to, it's easiest to do the oxygen last. So we'll look at something other than that first. I would try to balance my carbon. So if I put a 3 here, my carbons are now balanced, but, but my hydrogens and my oxygens are not. Okay, so if I have a 3 here and a 4 here, everything is now balanced. This is all I have to do with my combustion reaction. You do not have to write a net ionic or anything like that. All you have to do is write the equation and balance it. So the one right above it that's talking about octane, you're going to do the exact same thing and you're going to balance it. It's a little bit more difficult to balance that one, so I want you to try to do that on your own. Always leave the oxygen for the last thing that you're going to balance. Okay guys, if y'all have further questions, please email me or hop